theorem of calculus to answer the question. So what we have to do the fundamental theorem of calculus is you do it. Ooh, that's an aggressively big marker. I forgot that. Area. See, it's just I'm just trying to draw it nicely, give you know some pizzazz. All right. Our area is from what to what in the x's?
0 to 1.
0 to 1. So zeros go 0 to 1. Now, in order to do area between curves, the question is actually not hard to set up. The hardest part is figuring out which one is above and which one's below. Well, they told us. They're not going to. This is a nice one. You have to always do the area above minus the area below. Why? Upper one below. Why would you do that?
Because I can see the stuff in between.
Because it's the area below the curve, correct? When you do the fundamental theorem of calculus. Not fundamental calculus. When you do the fundamental theorem of calculus, it gives you the area under. So if I take the area under e to the x and I subtract from the area under y equals x, I would get the area between. Correct? That's why you subtract them. Yes. So I was agreeing with you and reiterating. Yes, humble as well. All right. So we're going to have e to the x minus what? X. And then behind that we put dx.
What does the dx mean?
You all. No, you let me tell the story, or you can just ask questions. We have the squiggle, aka the integral symbol, from 0 to 1 to tell you where we're going from and to on the x's. We have the equation in the middle because we're taking the area between the two curves, highest one minus lowest one, and the dx behind it to tell you that that's actually a derivative. That's how they tell you that that's a derivative, because there's no like f prime of x to tell you it's a derivative. We show it's a derivative by putting the dx. When we undo it, the dx goes away, and you actually get a plus c. What?
Why is it not a dy over dx? Like, to show, deliver no y's?
It's just integral. There's just an x here. Like, there's no y to begin with. It's just area equals, right?
Yeah.
Yeah.
Okay, that's a good question, John.
All right.
I'll show you this.
So, we're going to, this is what we're going to do. Okay, how do we do this using the fundamental theorem of calculus? What do we do? We do the derivative, antiderivative of that. So what's the antiderivative of e to the x? E to the x. What's the antiderivative of x?
1 over 2x.
1 half x squared, and then?
Like a square bracket.
Plus c.
Plus c, and then a square bracket 0 to 1. Right? What?
Is there a plus c on the e to the x derivative?
No, this is the whole thing together. They put the whole thing together. So now it's just an equation. So. All right. So we're going to get e to the 1 minus 1 half 1 squared plus c minus e to the 0 minus 1 half 0 squared. Add that bracket. Plus c. And the plus c's cancel. It's the plus c, that's minus c. E to the 1, you can't make any prettier. It just stays in e. Because 2.718, blah, 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 blah. Minus 1 half. What's e to the 0? What's anything to the power of 0? 1. So you're going to go minus 1. And then a 0, and then that's gone. So you end up with e minus what? 3 halves. Where do you just because area? Okay, so this is the easiest type of between two curves area I could ask you. I actually told you which one was above, I told you which one was below, and I bounded it. Okay? Now what they can also do is they can also now just give you two equations and ask you for the area between them and not give you the x values. So if that happens, they have to give you two equations that overlap. These two equations didn't overlap, right? Like one was below and one is above the whole time, so it's not going to, they have to give you x's to bound it. But if they give you like a parabola that's concave down and a parabola that's concave up, there's going to be intersection points where you're going to have to find in order to know the area between those curves. Okay, so we're going to try that one out. Example. So, we're going to try and find the area of the region between the two, correct? So the first thing you're going to want to do is find out where the two intersect. This is a concave down parabola, the second one, this one's a concave up. So they will intersect in some spot, right? So, how do we find out? We have to first find the intersection points. I guess intersection x values. How do we do that? Set them equal to each other. That's exactly what we do. So we go x squared equals 2x minus x squared. And some people will say, well, why can I do that? Because y equals y. And then people are like, okay, cool, that's true, but what? Well, if y equals y, then x squared can go in for y, and 2x minus x squared can go in for that y, and I can set them equal to each other. Whenever you're finding intersection points between, or x values between something, you set them equal. Yeah?
Will this one calculator or non-calculator portion of our?
Could be on both. Yeah. If they put it on the non-calculator part, they'll often give you ones like, this is one that you could do, and it's not super crazy complicated.
Yes.
Okay. So we're going to add the x squared over, bless you, and subtract 2x. So I'm going to get 2x squared minus 2x equals 0. Why did I move everything to one side?
So we can make it zeros.
Why did I want to make it equal to 0? And why did I do that? But why? Why couldn't I have just moved the 2x over and divided by 2x?
Because if you wanted to solve for anything and you would have looked silly, with
Because
having
it's,
x's on both sides.
what I'm looking for is, it's a quadratic. It's an x squared. And when you have a quadratic, you have to move everything to one side so it's equal to 0. That's what I was searching for. But we do that because if not, you would look silly. I'll agree with that. Okay. What can we do here? GCF a 2x out. I have made you guys remember that. Getting a 30-1, it was not there. All right, 2x squared, take out a 2x, I'm left with x. Minus 2x, take out a 2x, I'm left with 1. So what are my two numbers? X equals 0
X equals 1.
and 1. So I know for area, I'm going to end up with 0 and 1 here. Right? Now my next step is, I have to figure out which one is higher than the other one.
Can we just plug in like the number in the middle?
You can plug in a number in the middle and see. So we could plug in 0.5. So I could go y equals 0.5 squared. And I could go y equals 2 times 0.5 minus 0.5 squared. Should be like 0.1 half. I did one of these yesterday. Nope, it's not the same thing. So it's going to be 0.25. This one is going to be half of 2, so 1 minus 0.25, which is 0.75. Which one's higher? 0.75. So that's the one I'm going to write first. Yeah.
Oh, wait, never mind. I was going to say, could we have just assumed the one that's concave down should be the top, but then I remembered that you could have.
Now, it should be, the concave down one should be the top if we can find intersections. Because if it's not the top, and you had a concave down here and a concave up here, they're not going to intersect. So yes, you could go into shear assumption at this point. If you have one down, one up, and you found the intersection, the downwards one should be on the top. But we could have technically a concave down, a concave up, and then find the region between these ones, but we wouldn't find intersection points. So I just like proving with that second one is higher. But you could 100% do what you said. All right. So we're going to get 2x minus x squared minus x squared dx. Which I could do the derivative of that, or I could actually write it as what? because this is the first equation, this is the second.
Oh, yeah.
So we're gonna get 2x what? Minus 2x squared dx. I want you to get the area, go. The antiderivative would be 2x squared divided by 2 minus 2 over 3x cubed plus c from 0 to 1. Those cancel. And so I'm left with 1 squared minus 2 over 3. Guys, I say quiet and I swear you have like a buffer for my voice. So how about we listen? It's still you talking. All right. So we have 1 minus 2/3, which is?
Third.
And then that just goes away. Okay, I'm giving you an example and seeing if you can do it. Now, if I'm giving you this example, you have to find out, once again, which graph is higher. I'm going to give you a hint. What happens if partway through one graph is higher in that region I give you, and then the other halfway through they swap?
Like 2 different ones and add them together.
Do 2 different ones and add them together. Let's think about that. Okay. Find the area of the region. So, find the area of the region bounded by the curve y equals sine x, y equals cos x, x equals 0, and x equals pi over 2. You should be able to sketch the graphs between those because it's just from 0 to 90. Cos is Calgary Stampede, right? So you would do root 3 over 2 and then a half, or root 3 over 2, root 2 over 2 and a half for 30, 45, and 60, and to 90. You should be able to sketch a sine and a cos graph from the unit circle. It's the first 90.
I get what you're saying as well.
Calgary Stampede. Oh my gosh. It's as if you guys have forgotten about me and all my knowledge that I gave you in 30
Is it
lessons.
between x equals 0 and x equals?
Oh, Molly, that you didn't know that till right now scares me because you even wrote the diploma in there. Boy.
I just remembered it was close.
Well, there you go. Yeah. So this is the coses. So you would go 0.707 or 0.8660, 0.707, 0.5, and then this one is at 0 and 1. That's what the decimals are to these. And then this would be 0.5, 0.707, 0.866, and 1. So you can sketch them, right? This is at 30, 45, 60, 90, or pi over 6, pi over 4, pi over 3, pi over 2. Go. So I sketched the 2 graphs. The first, area 1, has cos above. It's from 0 to pi over 4, right? And the second one has sine above. So we could go area, okay, go away, equals 0 to pi over 4, the cos on the top, so cos x minus sine x dx, plus area 2, which is pi over 4 to pi over 2. Sine is on the top, so sine x minus cos x dx. So when we do the antiderivative of cos x, we get sine x. The antiderivative of negative sine x is positive cos x plus c from 0 to pi over 4. Plus sine x, the antiderivative of sine x is negative cos x. Antiderivative of negative cos x is negative sine x plus c from pi over 4. Pi over 2. And so we're going to get sine of pi over 4 plus cos of pi over 4 plus c minus sine of 0 plus cos of 0 plus c. Sine of pi over 4 is root 2 over 2 plus root 2 over 2 minus sine of 0, which is 0, plus cos of 0, which is
1.
1, And so I get 2 root 2 over 2
Minus,
minus 1. That's root 2 minus. Wait a second, I didn't do the second half. But I times it by 2.
you're a genius. It's almost like they're symmetrical.
It's almost like they're symmetrical. The area's the same. Oh, the crowd goes wild.
I'm gonna do that too, so.
Yeah.
Yes.
You could do this one. You'll prove that you get the same answer, right? Add the 2 and you get that. If they had cut it off at like pi over 3, you can't do that, correct? Because then they're not symmetrical. It's only because the actual sine and cosine graphs are symmetrical about it. I bypassed this completely. I didn't do this, and I didn't do this. I just did this. Right? I just times it by 2. Because me be lazy.
Maybe lazy.
Me be lazy. And I times it by 2 the whole way. And didn't do that second area. Right? But can you do the second area, get the same areas and then add them?
Yeah.
Get the same answer? Yes. All right.